All right, so let's talk about the molecular formula. So the molecular formula is sort of tied into the empirical formula. Now the definition of it is that it's going to show you the actual number and also the kinds of atoms in a single molecule. So how I like to think about this is that the molecular formula is simply the empirical formula scaled, right? Now it's not going to get in the same units because you're not writing it really in the same form, except you're going to be using a certain scale factor to write it in a different form that's going to be related. And that's why it's referred to as a molecular formula, because you're writing it still in molecular form. So the two steps that you want to take is, first you want to find the gram formula mass for your given, right? So gram formula mass, and then you're going to want to find the scale. You want to find the scale, and how you're going to do this is you're going to use or find the molecular mass or gram formula mass in this situation. So this is whatever you found up here, and you're going to divide that by the empirical mass. So in order to do this, say you're given something like 16 grams of carbon, 5 grams of hydrogen, or something like that, you're going to have to use the empirical formula first to find the empirical mass, and then find the molecular mass. So your molecular mass, this value right here, is before the empirical. All right. So let's just have a practice example real quick here. Let's say we had the empirical formula of C2H4 oxygen. So how you want to do this is find the empirical mass, because that's the first section here that we need to find. So C2 is going to be equivalent to 24. We're going to add H4, which is just going to be 4, and then oxygen is 16. So that's going to give us 44 EMU, right? So now we know our bottom part, but we still need to find the molecular mass. And so how do you find the molecular mass? Well, in this case, you're going to be given something called the molecular mass, right? You're going to be given the molecular mass because you're not going to be explicitly solving for it. So your molecular mass, let's say for this situation, it's something, say like 88, right? It's going to be 88 grams per mole. And so what you're going to do with this equation is this equation helps you find the scale, right? And so then using this scale, you're going to find the molecular formula. So since we know the molecular mass is going to be 88, and then we have the empirical mass, which is 44, we know the scale is 2. And so the scale from the empirical formula to the molecular formula will be 2 times. And so what do we have up here, right? What do we have up here? Let's just bring everything down. So we're going to have C2H4O as our empirical formula, except now that we have our molecular formula, everything is going to be applied to a 2x scale factor, right? So 2 times 2 is going to be C4, 2 times 4 is going to be H8, and 2 times 1 it will just be oxygen 2. And so that is your molecular formula.